This video lecture demonstrates the use of BC command in UNIX. BC command is used as a command line calculator. The user can do basic mathematical calculations using BC command. Let us now learn to differentiate BC command against EXPR command. The BC command evaluates from standard input, whereas the EXPR command evaluates an expression from its arguments. The BC command is used to do both integer and floating point arithmetics, whereas the EXPR command is used to do only integer arithmetics. The BC command has exponentiation, square root operation, library function, and its own scripts like any other programming language, whereas the EXPR command lacks all these features completely. The BC command supports the arithmetic operators such as plus, minus, star, slash, and percentage. The BC command also has an exponentiation operator, which is represented by an upper caret character. EXPR1 upper caret EXPR2. The result of the expression is the value of the first raised to the second. The BC command supports the assignment operator. It also supports increment and decrement operators. The BC command supports relational operators such as less than or equal to, greater than or equal to, and not equal to. The BC command supports logical or Boolean operators such as AND, OR, and complement. The BC command has its own set of library functions. To state a few functions, S of x will return the sine of x where x is in radians. C of x will return the cosine of x where x is in radians. L of x will return the natural logarithm of x. E of x will return the exponential function of raising e to the power x. SQRT of x will return the square root of the number x. Length of x will return the number of digits in x. The scale function is used to increase the accuracy of the floating point calculations by specifying the number of digits after the decimal point. I-base, O-base functions are used to convert the numbers from one number system to another number system. I-base stands for input base and O-base stands for output base. Let us now see the demonstration of BC command. The BC command is given at the $prompt. It goes inside the BC utility. When we gave 100 plus 200, it has returned 300. When we gave 100 minus 200, it has returned minus 100. When we gave 100 star 200, it has returned 20,000. Then we have given scale equal to 5 so that to increase the number of decimal digits after the decimal point. When we give 100 slash 200, it has given the result as 0.5. When we gave 100 percentage 25, it has given the result as 0. Just to demonstrate, the BC can do both integer and floating point calculations. Floating point arithmetics are given now. 1.1 plus 2.2 has returned 3.3. 1.1 minus 2.2 has returned minus 1.1. 1.1 star 2.2 has returned 2.42. 1.1 slash 2.2 has returned 0.5. Then we have also demonstrated the exponentiation operator, which is available in BC. 6 upper caret 2 has returned 6 power 2, which is 36. 2 upper caret 10 has returned 2 power 10, which is 1024. Assignment can also be used inside the BC utility. I equal to 10 assignment is made. Then I plus plus is given. So this has displayed the value of I as 10. Afterwards the I has been incremented. Then plus plus I is given. So I value is 11. Now when it is incremented by 1, it has become 12. So the BC utility has returned the value 12. Similarly, I minus minus is given. So the value of I is displayed, then the value is decremented. So it has returned the value 12 again. So minus minus I, now the value is again decremented by 1. So from 11 it is decremented to 10 and the value 10 is displayed. To demonstrate that the relational operators can also be used inside the BC utility, relational expressions are given. 10 less than or equal to 20 has returned the value 1 as the expression is true. 10 less than or equal to 5 has returned the value 0 as the expression is false. 10 greater than or equal to 10 has returned the value 1 as the expression is true. 10 equal to 10 has returned the value 1 as the expression is true. 10 equal to 20 has returned the value 0 as the expression is false. 10 not equal to 20 has returned the value 1 as the expression is true. BC utility has to be invoked with the option -L in order to use mathematical functions. To demonstrate that BC supports relational and logical operators, we have given logical expressions. 5 less than or equal to 10 double ampersand 20 less than or equal to 30 has returned the value 1 because both expressions are true. 5 greater than or equal to 10 double ampersand 20 less than or equal to 30 has returned the value 0 because the first expression is false. 5 less than or equal to 10 or 20 less than or equal to 30 has returned the value 1 because both expressions are true. 5 greater than or equal to 10 or 20 less than or equal to 30 has returned value 1 because the first expression is false but the second expression is true. To represent complement, we use exclamation mark. So exclamation 5 less than or equal to 10 has returned value 0. Exclamation 5 greater than or equal to 10 has returned the value 1. The library function s of x denotes sin of x, c of x denotes cos of x, where x is in radians. So we have used a formula x is equal to 3.14/180 into 90 so that 90 degrees can be converted into radians and it is given to the variable x. We have used a formula pi radians is equal to 180 degrees for the conversion. Then we have given scale equal to 3 in order to fix the number of decimal places after the decimal point. Then we have given s of x, it has returned a value 1 because s of 90 is 1. We have given c of x, it has returned the value 0.001 because cos of 90 is 0. I would like to draw your attention that x denotes the radians which is equivalent of 90 degrees. SQRT 81 has returned the value of 9. SQRT 25 has returned a value of 5. Length 1, 2, 3, 4, 5, 6 has returned the value of 6 which is the number of digits of the given argument. Length 876 has returned a value 3. I base is equal to 10, O base is equal to 2 will convert any input in base 10 to base 2 as output. So when 10 is given, it has given 1010 which is equivalent of 10 in binary system. When we gave 20, it has returned 10100 which is equivalent of 20 in binary. Then we have given I base is equal to 10, O base is equal to 8. Since we have given I base is equal to 10, O base is equal to 8, any input that is given in decimal number will be converted into an octal equivalent. Hence, when 625 is given, it has returned 1161 as a result. 1161 is an octal equivalent of 625 in decimal. Then we have given I base is equal to 10, O base is equal to 16, which will take input in the decimal number system and it will give the result in hexadecimal number system. When 10 is given, it has returned capital A. Capital A is a hexadecimal equivalent of decimal number 10. Then when we gave 11, it has returned the value of capital B. When we gave 125, it has returned the value of 7D. 7D is a hexadecimal equivalent of 125 in decimal. Thank you.